Welcome to 3.1. We're on page 2 now, and we're going to get to that real shortly. Exponential functions and their graphs. Now, these formulas are not addressed in this section. Really important formulas for us. They're financial based, and they're really nice to understand what's your best, what's going to give you the best results as you move into a world where you're going to be investing money, hopefully, and anyway, so we're going to have more talk about those, but not in this section. We're going to keep it pretty basic, just kind of getting a feel for what an exponential function is when we have variables in the exponent. In this section, we're to use the graph of y equals 2 to the x to try to match it. So probably worth jotting this. So I'll have you jot this down here. I'm just going to graph 2 to the x. I'm not going to put a whole lot of points on here. I'm just going to go x is 1, 2, 3, negative 1, 2, 3, and we go up 1, 2, 3, 4, 5, 6, 7, 8. I got a smaller y scale. Put in 0, get out 2 to the 0th 1. Kind of just review from the last page. Put in 1, get out 2. Put in 2, jump up to 4. And put in 3, jump all the way up to 8, put in 4 up to 16, so this thing's really taken off now. Put in negative 1, we get a half, 2 over 1, or 1 over 2 to the first. Put in negative 2, 1 over 2 to the second, 1/4, and we're getting sucked into 0 this way. Okay, so ideally, we wouldn't do this. We wouldn't look at number 18 and say, okay, put in 0, get 2 to the negative 0, 2 to the 0th 1. Put in 1, get 2 to the negative first, 1 on 2. Put in negative 1, get 2 to the first 2. Ideally, we're going to say, well, I'm looking for this graph except pre-function multiplier. That's changing the x. What was to the right is now to the left. So like this point that was to the right would now be to the left. This point was to the left would now be to the right. So this is backwards version of that. So it still goes through 0, 1, and it's backwards. And that's the only one that looks like it could fit. Looks just like f of x, looks just like 2 to the x, looks just like this function, except we add 1 to the function value. The function value, I'm not adding 1 to x, I'm adding it to y. The function value 2 to the x plus 1, so this is 1 higher, so it looks just like this, and up 1, it's got to be b. Okay, now, I'm not going to have you in this section sketch the graphs. That's why there's not much room here. This is our top skill for the entire semester. Our top skill is just knowing how a function, much like what we were doing up here, relates to a parent function. So how does g of x look compared to f of x? Well, we're adding 4 to x, and that's a common mistake. People are going to say, oh, well, that moves it to the right. Nope. To get credit for putting 0 in to this function, to get credit for 0, like if this was 0, x would have to be negative 4. The myvox is negative 4. That's 4 to the left. Or think of it, hey, that's either a right-left, but it's a 4-day head start. What normally happens on day 5 would now happen on day 1. That's 4 to the left. So this is just left 4. Okay, now if you were just looking at g of x, you might say, well, we multiply 2 to the x by negative 1, so upside down, and then we add 5. You might want to think of this as negative 2 to the x plus 5. So you might say upside down and up 5, and I understand it, but we're comparing this graph to a graph that's already upside down. So the only difference is we're up 5. And this graph, however, see, it's not even important, you don't have to draw this, but here's 0.3 to the x. It's going to look something like this. You don't even have to know it to answer this. We're going to know that, well, the 0.3 to the x is represented here. We multiply that function result by negative 1. We multiply y by negative 1 upside down. And then we add 5 to the function up 5. myvox negative 2, 2-day head start. Everything happens 2 days sooner. That is left 2. we subtract 3 from the function, that's 3 from the y, down 3. And here we got two pre-functions. The bivox, notice, is -4. I put in -4 and I get 0 up here. That's left 4. And this negative is being multiplied by the x, not the function value, just the x. So what was to the right is now to the left. We are backwards. Okay, and let's take a look. Here we are to graph the function, find asymptotes by creating a table of values. We may just do that from the graph, but maybe we'll take a look at it both ways. This is a quick video. So let's go y equals, I'm going to go alpha y equals, get my fraction. 54, I've got 8 on 1 plus -0.5 on, whoops, hang on. Delete, my fault. I need an e raised to that. You got two options here. Here's an e. You can go second e, get that e, and then caret it to the -0.5x. Or e is very oftentimes, when you're using e, it's going to be to an exponent, so they have a second button here above ln, e to the x. I'm going to use it, second e to the x, and I need -0.5 divided by x. And I'm going to zoom standard this, zoom 6 for zoom standard. That's -10 to 10. And it looks like we're hanging right around 3 or 4. Looks like we're hanging right around 4. So there's our function, and they want us to go to table and do this. So I'm going to go second table. Oops, let's go table set first. Table set. I'm going to start at 0, and I'm going to count by just I'm going to go by like 0.5s. Sorry about that. So I went into second table, and I'm starting at 0 and I'm counting by 0.5s in my table, and now I go to table. And we see 0 is an error, so it makes me think like, you know, if I look at the graph of that thing, makes me think like it's an asymptote. Here's the deal, however, this is never, let's come back and think about it, because it definitely looks asymptotal. But watch this, if I put in second calc value 0, we don't get a value. But if I put in 0.0001, it tells us we're at 8 there. It's not getting up close to infinity. So let's think about this just for a moment. E is a positive value. A positive value, much like 2 up here, raised to a power can never be 0, but it can get close to 0. This can get close to 0, but it's always positive. And 8 divided by 1 close to 0 is close to 8. That is truly not an asymptote, even though it looks like there's a vertical asymptote right here. Now, if I go back to my table now, second table, and I start just moving down the chart, it starts to seem like maybe we're just approaching 4. And we could do the same thing to the left, and you're going to get another approach. Let's go back here. Can I just put in 0? Nope, I got to go all the way back here. And hold with me here. This is why I'd rather look at things from the graphs I'm going to show you. You're going to see over this side we're closing in on 4 from below. Another way that I prefer to do this would be if I go into window, I'm going to go -100 to 100 and figure out what's happening when the x's get big. I'm going to graph that, and I'm going to trace. The graph pretty much just looks like a horizontal line except right around 0. And as I trace out here, it starts to become pretty suspicious that, hey, it does look like we're closing in on 4. And I think you can see that that can be a lot more efficient than using the table. Not that it doesn't have its place, and I know some people prefer it. So I believe we have a horizontal asymptote of y equals 4. Now we can try to make some sense of that, and there'll be a time that comes that we actually will. But think about this one just for a moment. As x gets really, really, really big, this becomes e to the virtually 0, and e to the 0 is 1, and 1 plus 1 is 1, or 1 plus 1 is 2, 8 divided by 2 is 4. So some of that stuff is predictable, and it's kind of nice to predict it. Use a graphing calculator. So since we used a graphing calculator, we're going to go ahead and just say, if I go back to Zoom Standard, let's get a graph of that thing. We're going to go ahead and get that graph drawn in here. So it looks like we've got a horizontal asymptote at 4. Looks like we come down and we just get sucked right in here to 0. And it looks like we're go up here, and we've already got some evidence of this, 4, 5, 6, 7, 8, that we come up into here. They look like that. Okay, so let's see, did we answer everything? Graph the function, yet find any asymptotes numerically by creating a table of values of the function. Got it. So 56. So you can just do some editing here. 6, 2 minus e to the, delete that, 0.2x. So you definitely see some similarities, and it probably wouldn't be a bad idea to kind of do some reasoning here. What happens as x gets big? As x gets big, e to the 0.2 on a big number is like e to the 0th, which is 1. 2 minus 1 is 1. I wonder, do we have a horizontal asymptote of y equals 6 here? Let's go Zoom Standard. Look at that. There we are, up right close to 6, it looks like. And then we jump to the other side a little bit. Interesting. I'm going to go back and check my y equals. We'll confess to being a little bit surprised by that. Okay, so we go back to window, or we go back to graph, and we see we got some interesting things happen. Let's go ahead and do a quick trace on this. I'm at 0, it doesn't live, and then we step across and we're actually negative for a moment, and that's because we have 2 minus a fairly big value. So kind of an interesting graph here. We'll just graph it as it looks. I suspect that there's just a little tiny gap in the graph there, but we'll just graph it as it looks. I do believe this is up at 6, and we come up, we look something like, I don't know, we could put 0 in here. Oh, 0 is undefined, so we got some issues there. So something strange is going on. We'll just go with what the graph shows on the graphing calculator. And then this side looks a little bit more clear. Okay, so let's go ahead and go to our table. I'm going to go back to table set, second table set. I'm going to get us back to 0, and I'm kind of curious what's going on around 0. Let's just put in 0.1 here. And let's go to table. You know, some of this is just arbitrary decisions. We realize 0 is a problem, and then we get some negative values. Oh, we actually get some negative big values here. And the reason that's happening is because the denominator can actually become 0. Take a look at 54. The denominator can't become 0 but in 54, so we don't have a vertical asymptote, but it does look like we have a vertical asymptote here. And now, just kind of trying to figure out where that is right now, let's go back to, because we get that error, we jump somewhere between 0.2 and 0.3. Watch how I handle this. See how we're jumping from a relatively big negative to a really big positive. I'm going to go to my table set, 0.2, 0.3. Second table set. I'm going to start at 0.2. I'm going to jump to I'm going to start at 0.2, and I'm only going to step by like 0.01s. Let's take a look Let's take a look at that in our table. See what's happening here? Pretty clear we have an asymptote in the 0.28, 0.29 region. So I'm going to remember those 0.28, 0.29. I'm going to go to my table set. I'm going to start at 0.28 and I'm going to now step by 0.001. And let's go to table. Take a look at that. We got a vertical asymptote approximately at x equals 0.28. You could go 288, 289, 0.288. We got one right in there, 0.288 or 0.289, somewhere between there. We could keep closing in on it and closing in on it. There is a way, of course, to mathematically find the exact value, but we don't have that capability yet. So kind of an interesting one right there, a good search one. As you can see, we're going to have the same kind of issue on this problem right here because the denominator can be 0. So got a little seeking to do there. Let me know what I can help you with. But that's it for this section. Good luck.